This is the joint life sheet in the ALTAM Excel workbook. It is a standalone engine. Independent lives, same Makeham law as the single life tab. The sheet builds same age joint factors on XX, then two age factors on x:(x+10). Last survivor is not computed here. Cell G2 is the only interest input, I equals 0.05. Discount D is I over 1 plus I, which Excel stores as 0.047619. V is 1 over 1.05, equal to 0.952381. Force of interest delta is the natural log of 1.05, equal to 0.048790. Those four numbers rebuild every later column. The header also types M equals 12 and computes D upper M as 0.048691. That is the same identity as the interest functions tab. Joint life does not use it. There is no Woolhouse column on the sheet. Leave J2 and J3 alone when you rebuild the joint engine. Makeham A is 0.00022. B is 2.7 times 10 to the minus 6. C is 1.124. Those are the standard ultimate survival model constants. The joint life tab pastes them. It does not read the single life sheet. If you edit one tab, the other stays put. Column C is 1 year survival under Makeham. The Excel formula is the ALTAM closed form, exponential of minus A plus B over ln C times C to the X times C minus 1. That is exactly cell C9, copied down to age 130. At age 20, ln of 1.124 is 0.116894. C to the 20 is 10.3592. The Makeham inner sum is 0.000250. Exponential of the negative is P20 equals 0.999750. That is the cached value in C9. Copy the formula down. At 40, Px is 0.999473. At 60, 0.996602. At 80, 0.967342. At 100, 0.710416. Makeham is almost flat in the 20s, and then the BC to the X term takes over. Column D is lives. D9 is typed 100,000. Every later row is the row above times that row's Px. So L21 equals 100,000 times 0.999750, which is 99,975.04. L30 is 99,727.29. You will need L30 when the 2H column multiplies Lx by Lx plus 10. Independent lives, same age. The joint life status survives the year only if both survive. Excel just squares C9. P20 times P20 is 0.999501. That is cell E9. There is no common shock term on this tab. At age 20, the gap is tiny, 0.000249. At 60, Pxx is 0.993215 versus Px of 0.996602. At 80, Pxx has fallen to 0.935750. At 100, it is only 0.504691. The joint status fails at the first death, so it decays faster than a single life. Column F is a second radix, also typed 100,000 at age 20. Then F10 equals F9 times E9. Joint lives at 21 are 99,950.08. At 30, they are 99,455.32. Compare that with single life L, 30 of 99,727.29. The joint table is already thinner. By age 80, 75,657 single lives remain, but only 57,240 joint pairs. By 100, the joint radix is 390 versus 6,248 single lives. Pure endowments and annuities read this thinner LXX column, not LX. Column G is the 10-year joint pure endowment. Discount 10 years and keep only the pairs still jointly alive. In Excel, that is V to the 10th times F19 over F9. V to the 10th is 0.613913. Joint lives at 30 are 99,455.32. Divide by the age 20 radix of 100,000 and multiply. Cell G9 is 0.610569. Almost all of the 0.6139 discount survives because joint mortality is still tiny from 20 to 30. "20 years uses F29, the joint radix at 40, which is 98,680.89. V to the 20th is 0.376889. Cell H9 is 0.371918. Temporary annuities later subtract these endowments times a later due annuity. This sheet does not build those temps. Single life does. At 40, 10E is still 0.604532. At 60, it is 0.545400. At 80, it has fallen to 0.187764, and 20E is only 0.002571. At 100, both are essentially zero. High-age rows that look past the last LXX cell become 0 or divide by 0. Stay in the ages that still have x plus 20 on the sheet. Column I is the joint life due annuity. Payment of 1 today, plus V times PXX times the annuity 1 year older. That is a backward fill. The last age 130 has no row below, so Excel treats I120 as 0 and A double dot at 130 equals 1. No iteration is required. I10, the age 21 annuity, is 19.52176. Multiply by V and by PXX at 20, then add 1. Cell I9 is 19.58287. That is the whole life due annuity on 2 independent 20-year-olds under this Makeham table. Column J never sums a series of V to the KQ. It uses the discrete identity A equals 1 minus D times the due annuity. 1 minus 0.047619 times 19.58287 is 0.067482. That is cell J9. At age 130, the annuity is 1, so A is 1 minus D, which is V, 0.952381. The sheet stores 0.952381 in J119. At 40, AXX is 17.62835 and AXX is 0.160555. At 60, 13.24968 and 0.369063. At 80, 6.47944 and 0.691455. At 100, 1.82228 and 0.913225. Every row satisfies 1 minus D times A, including the terminal row where A130 equals 0.952381. Column K is the second moment due annuity. Same backward recursion, but V is squared. That is interest at force 2 delta. Terminal condition is again 1 at age 130. You do not rebuild mortality. K10 is 10.63758 times V squared times PXX plus 1 gives K9 equal to 10.64379. That is much smaller than the first moment annuity 19.58, as it must be heavier discounting. The second moment insurance identity uses 2D minus D squared, which is 0.092971. 1 minus that times 10.64379 is 0.010442. Cell L9. Variance of present value is second A minus A squared when you need it on exam day. This sheet stops at second A. At 20, second A is only 0.010442 against A of 0.067482. By 80, second A is 0.501652 and A is 0.691455. At 130, both second A and first A equal 1, and second A equals 1 minus 2D plus D squared, which is V squared, 0.907029. Same terminal logic as column J. Column M is not a recursion. It multiplies the two single life counts and divides by the radix. At age 20, that is 100,000 times L, 30 over 100,000, so M9 equals L, 30, 99,727.29. At age 40, it is L, 40 times L, 50 over 100,000, which is 97,924.05. The 2H due annuity is the same backward identity, but survival is M10 over M9, not E9. That ratio is 0.999435. Times V times the age 21 2H annuity 19.05635 plus 1 is 19.13865. Cell N9. Smaller than AXX of 19.58287 because one life is already 30. O9 is 1 minus D times N9, equal to 0.088636. That is larger than AXX of 0.067482. The 2H status fails sooner, so insurance EPV rises. Second moment columns P and Q reuse V squared and the 2D minus D squared identity. P9 is 10.59325. Q9 is 0.015140. At every age, the 2H annuity is smaller and the 2H insurance is larger. At 60, AXX is 13.24968 versus A, 60:70 of 11.22196. AXX is 0.369063 versus 0.465621. Columns N and P stop a few rows before M because they look one row down. Do not copy those formulas onto the last filled M row. Every point is a cached Excel value. The red curve is AXX. The orange curve is AX:(x+10). Both start near 19 and fall toward 1. Orange stays below red at every age. One life is older, so the joint clock fails sooner, and the due annuity is smaller. Insurance is 1 minus D times the annuity, so the curves rise as the annuity curves fall. Purple AXX starts at 0.0675. Orange two-age insurance starts higher at 0.0886 and stays above. Yellow second AXX starts at 0.0104 and climbs toward V squared. That is the whole first versus second moment picture on this tab. Last survivor A double dot on two same-age lives is AX plus AX minus AXX. The joint life tab does not compute it. You would take the single life due annuity and this tab's AXX and subtract by hand. Same idea for last survivor A. Do not hunt for a hidden column. The used range looks huge because of leftover empty grid. Exam day you get a blank book. Type 1, Makeham ABC, and 2 radix cells. Fill px, square it, recurse both L columns. Pure endowments are V to the N times a later joint radix. Annuities fill backward from age 130 equal to 1. Insurances are 1 minus D times A. 2-age uses the product of single life Ls. That is the entire joint life engine.